Probably one of the more common tools used by hackers once they're on the physical network are sniffers. And sniffers are in use all over the place. A lot of systems administrators use these, and they're very easy to get your hands on, and they're extremely effective for analyzing network traffic, which is definitely a key requirement of penetration testing. And the idea here is that the host that houses the sniffer software picks up all traffic on that wire, even if it isn't intended for the host where it is installed. It basically places the network card into something called promiscuous mode, which is listening for any traffic that crosses the wire. Sniffers have become significantly less effective over time because switches no longer forward unnecessary traffic to hosts attached to that device. Now, there are more advanced sniffers and more advanced techniques for sniffing networks aside from a standard promiscuous-based sniffer. But the overall concept, regardless of the technology you're using, is to steal or eavesdrop on network traffic as it crosses through the wires. This can enable attackers to pick up plain text data, which could be user credentials. I've also seen scenarios where a sniffer was able to pick up a URL sent between a web server and the SQL server in the back end that housed the actual select statement in plain text. And usually directly following that, we're going to see a communication back to the application with the results of that select statement. So oftentimes you can pick up sensitive data by watching the wire as well. For all intents and purposes, our sniffers are going to require physical connection and physical location in proximity to the network you want to sniff. The only exception to that rule being that wireless sniffers do not have to be in close physical proximity to operate. Sniffers come in the form of software that can be installed on systems or even physical hardware devices that output to a system. The term promiscuous mode is used quite a bit to describe the process of sniffing because it is one of the requirements of gathering traffic intended for other hosts. The sniffing process is extremely useful because it will actually record that traffic and allow you to save it locally and potentially use cracking techniques to crack network-based encryption locally on your system. So you could literally go sniff traffic for an hour, take it offline, save it, and go off-site to attempt to read through and analyze that captured traffic. There are several possible sniffers that you might be able to use. A lot of these actually have ports over to Windows and Linux. Ethereal is probably one of the most common and most functional open source sniffing tools out there. Etherape is also a very commonly used sniffer that works extremely well on Linux. Same goes for Ettercap. Now, the Network Monitor utility is a Windows-only Microsoft product that usually ships with various support packs for Windows Server and Windows Client operating systems. Now, I will warn you, Network Monitor is not a very effective sniffer tool. Although it does put the network interface into promiscuous mode, oftentimes it will filter out traffic that it deems as not being valid to the sniffing session. So be very cautious about the reliability of the traffic you're seeing in a Network Monitor scenario. For Windows operating systems, sniffers have to be complemented by special protocol drivers that enable promiscuous mode. Whereas in Linux, you can simply use the ifconfig utility to place your network card into promiscuous mode. The software that's most commonly used to place Windows NICs into promiscuous mode is called WinPCAP and is freely available for download all over the internet.